Hi guys, today we're going to take a look at question 7 of the 2017 exam paper 1. Okay, so sometimes it is possible to predict the future population in a city using a function. The population in Sapphire City over time can be predicted using the following function. P of t equals s times e to the 0.1t times 10 to the power of 6. And the population in Avalon over time can be predicted using this function. Q of t equals 3.9 e to the power of kt times 10 to the power of 6. In the functions above, t is time in years, where we start from the beginning of 2010, and both s and k are constants. Okay, so on to part A. The population in Sapphire City at the beginning of 2010, so that's just before you even read the rest, beginning of 2010. So this means that t equals 0. Okay, and the population at this time is 1,100,000 people. Find the value of s. Okay, so the population at this time, so we have this population formula, P of t equals s times e to the 0.1 t by 10 to the power of 6. Okay, and for t equals 0 at the beginning of 2010, the value of this function, the population of the city, is 1,100,000. Okay, and now we can use this to solve for s. So p of 0, so s e to the 0.1 by 0 by 10 to the power of 6 is equal to 1.1 million. 1,100,000. Okay, so if we divide by 10 to the power of 6, we get s times e to the 0, which is just 1. So s equals 1,100,000 over 10 to the power of 6. And then if we put this into our calculator, we just get s equals 1.1. Now for part B, find the predicted population in Sapphire City at the beginning of 2015. Okay, so beginning of 2015, so this is 5 years from the beginning of 2010. So t in this case is 5. And so we're trying to predict the population here. So we have our formula for the population. P of t equals 1.1, the s that we just found, e to the 0.1 t by 10 to the power of 6. So then if we sub in 5 for t, the population after 5 years, then we get 1.1 by e to the 0.1 times 5, 0.5, by 10 to the power of 6, which equals 1,813,593. And now this is always going to be a whole number, so the answer we'll get is not a whole number, but we should always round to the nearest because we're talking about people here, so we obviously can't have, 0.3 of a person. So the predicted population at the beginning of 2015 is 1,813,593. Now on to part C, find the predicted change in the population in Sapphire City during 2015. Okay, so we're looking for the change in population throughout the year of 2015. So another way we could phrase this is the population at the end of the year or at the start of the new year, population at beginning of 2016 minus the population at the beginning of 2015. And that will capture the difference throughout the year. Or more like the predicted population at the beginning of 2016 minus the predicted population. So we could probably put in the predicted, because we're looking for the predicted change. You know, we don't know what the actual population will be. Okay, and so we can calculate this predicted population at the beginning of 2016. That's just t equals 6. So 2016. So t equals 6. So we can use our formula, our population formula, which again is 1.1 e to the 0.1 t by 10 to the power of 6. So if we put in t equals 6, we get 1.1 e to the 0.6 by 10 to the power of 6, which equals 2,004,331. Well, round to the nearest number. So that's the predicted population at the beginning of 2016, and we already know the predicted population at the beginning of 2015. It is 1,813,593. So the predicted change in the population throughout the year of 2015 is just the difference of these two. So 2,004,331 minus 1,813,593, which equals 190,738. So this is the predicted change in the population in Sapphire City during the year 2015. Now on to part D, the predicted population in Avalon at the beginning of 2011 is 3,709,795 people. Write down and solve an equation in K to show that K equals minus 0.05, correct 2 decimal places. Okay, so the predicted population in Avalon at the beginning of 2011 is 3,709,795 people. And we have a formula given to us for the predicted population of Avalon in a given year. So Q of T equals 3.9 e to the kt by 10 to the power of 6. By 10 to the power of 6. Okay, and at the beginning of 2011, well, this is 1 year after the beginning of 2010, so t equals 1. So for Q of 1, the population in Avalon in 2011 is 3.9 e to the k times t, which is just 1, by 10 to the power of 6. And they've given us this population. It is 3,709,795 people. Okay, so, well, we actually already, almost by accident, we've already constructed an equation in K. The only unknown variable here is our K. And now they want us to solve this equation. Okay, so if we divide by 10 to the power of 6, we'll get 3.9 e to the power of k equals 3.709795, because 10 to the power of 6 is a million. And then if we divide again by 3.9, we get e to the power of k equals 3.709795 over 3.9. So we're now solving for k. So we have this equation here, e to the power of something equals this fraction here. And so this equation is in and of itself a question. And the question is, e to the power of what equals this fraction here, 3.709795 over 3.9. E to the power of what equals this? And we actually have a way of expressing this question in a nice little expression. And we can capture this question by the log of e to 3.709795. That's what the log of e, that's what the logarithm does. The logarithm asks this question: the base to the power of what, the answer to this log, the base to the power of what equals what's in the brackets. That's what the logarithm is. That's how the logarithm is defined. So if we rewrite this, we will get our k, that's the e to the power of what. And if we put that into a calculator, we get minus 0.05, which we know that's what we were looking to get. So we're confident that this is the right answer. Now on to part E. We want to find the year during which the populations in both cities will be equal. So the year during which the population in both cities will be equal. Okay, so first of all, we have our formulas for the population in both cities. P of t equals 1.1 e to the 0.1 t by 10 to the power of 6, and q of t, so this is the population in Sapphire City, and 3.9 e to the minus 0.05 t by 10 to the power of 6 is the population in Avalon at time t. Okay, so we want to figure out when these are equal, the time, so we'll let these be equal, and then we'll solve for t. We'll see for which t are these two equal? So let's let 1.1 e to the 0.1 t by 10 to the power of 6 equals 3.9 e to the minus 0.5 t by 10 to the power of 6. Okay, so straight away these 10 to the power of 6 will go. So we get 1.1 e to the 0.1 t equals 3.9 e to the minus 0.05 t. And now if we divide by 1.1, so e to the 0.1 t equals 3.9 over 1.1 e to the minus 0.05 t. And then if we multiply both sides by e to the minus 0.05 t, we get e to the 0.1 t by e to the 0.05 t equals 3.9 over 1.1. And so we can just, when you have a product of two powers, so something to the power of something by the same something, in this case e, to the power of something else, then you can just add the two powers. That's one of our first rules of exponentials. So this will just be 0.15t equals 3.9 over 1.1. Okay, and using this knowledge about the logarithms and what the logarithms are, we can rewrite this as the log base e of 3.9 over 1.1 is equal to 0.15t, which equals 1.2657 to 4 decimal places. Okay, and then it's very easy to solve for t. T equals 1.2657 over 0.15, which equals 8.44. Okay, so t equals 8.44 when they're equal. And well, what year does that correspond to? Well, that would be 8.44 years after 2010. So that will happen sometime around halfway through 2018. So the year during which the population of the two cities will be equal is 2018. So not too bad. Just solving an equation in t, remembering our rules of exponentials and how the logarithm is defined, and it's really not too bad. Now on to part F. Find the predicted average population in Avalon from the beginning of 2010 to the beginning of 2025. Okay, so we have this population function for Avalon. Q of t equals 3.9 e to the minus 0.05 t by 10 to the power of 6. And so we're looking for the average of this function from 2010 t equals 0 to 2025 t equals 15. Okay, and we have this formula for the average of a function. So the average of a function between a and b and it is 1 over b minus a times the integral from a to b of the function. The integral of the function. Okay, so in our case, a equals 0, b equals 15, and our function equals 3.9 e to the minus 0.05 t by 10 to the power of 6. So let's just write out what we're looking for. So the average population, and then we fill into this formula, equals 1 over 15 minus 0, so just 1 over 15, times the integral from 0 to 15 of 3.9 e to the minus 0.05 t by 10 to the power of 6. And, well, so we can take out this constant 3.9 by 10 to the power of 6, and then we're just left with e to the minus 0.05 t. So if we take out this constant, we'll get 3.9 by 10 to the power of 6, because with an integral, you can always just take out the constant. Same with the derivative. You can take out the constant and then just put it back in later. Over 15 times the integral from 0 to 15 of e to the minus 0.05 t dt. Okay, and now what is this integral? Well, the integral of e to the lambda t, so e to some constant by t, is just 1 over that constant, e to the lambda t. That's what the integral of this is, just in general. Because if you think about it, if we differentiated this, and the integral is just the anti-differentiation, then the derivative of this would just be lambda times 1 over lambda by e to the lambda t. So these would cancel, and we just get e to the lambda t. So that's sort of how to make sense that this would be the formula for the integral of e to some constant times t. So in this case, we get 1 over minus 0.05 e to the minus 0.05 t. Just make some space. Okay, so 1 over minus 0.05 is just minus 20. So we get minus 20 e to the minus 0.05, and then we have to evaluate it between our 0 and 15. So we'll start off with 0, 15, and then minus it evaluated at 0, minus 20 e to the minus 0.05 by 0. And so this whole thing, this thing in square brackets, is 10.55. Okay, so these square brackets, everything inside of the square brackets here is 10.55, and then we just reintroduce our constants, so we get the whole thing is just 3.9 by 10 to the power of 6 over 15 by 10.55 equals about 2,743,000. Now, how exact this will be will depend on how many decimal places you included here for the 10.55, but as long as it's in this ballpark, it should be fine. So the average population over these 15 years is about 2.743 million. Now on to the last part, part G. Use the function q of t equals 3.9 e to the minus 0.5 t by 10 to the 6, our population function for Avalon, to find the predicted rate of change of the population in Avalon at the beginning of 2018. Okay, so the predicted rate of change. So whenever you hear rate of change, you should immediately be thinking derivative. So we want to get the derivative, rate of change, and we're looking for the value of the derivative, the rate of change at the beginning of 2018, which is t equals 8. Okay, so, well, first things first, we've got to find the derivative. So we use our function q of t equals 3.9 e to the power minus 0.05 t by 10 to the power of 6. And now we want to find the derivative of this. Well, we can just take our constants to one side, like we did for the integral, 3.9 by 10 to the power of 6. And then just get the derivative of e to the minus 0.05 t. And the derivative of this is just the derivative of this is, well, bring down the constant, minus 0.05, and then this just stays the same. So if we remember our formula, the derivative of e to the lambda t, some constant by t, is just lambda e to the lambda t. So it's sort of like the opposite. It's sort of like the opposite of the integral, which we know the derivative is essentially the opposite of the integral. So for the integral, e to the lambda t becomes 1 over lambda e to the lambda t, and here it becomes lambda e to the lambda t. Okay, and so now we want to, so this is our q prime of t, and now we want to evaluate this at t equals 8, which is 3.9 by 10 to the power of 6 by minus 0.05 e to the minus 0.05 by 8. Put that all into the calculator and we get minus 130,712. And again, just because we're working with people, we'll round to the nearest number. So if we want to write out what this would mean in English, at the beginning of 2018, now they didn't actually ask for this, but they often would, so it's good to get into this habit of writing it in the context of the question. At the beginning of 2018, and also to think about what it is this number means. It's not just some random number. Like in context, it has some meaning to it. At the beginning of 2018, the population of Avalon is reducing, since it's a negative, at a rate of 130,712 people per year. And that's it. Long question, but none of the questions were particularly bad.